logarithmic and exponential equations. So I'm going to show you a little bit differently from the way that Alex shows you, in that, so if we have a number raised to a power b to the x equals y, if we want to rewrite this in logarithmic form, this is my base. So it's going to be log to the base b, log to the base b, and then we go over to the other side of the equation like this and grab the y of y equals, and then we come back over and grab the power. So what goes here comes from the other side. The log function and the exponential function are inverses of each other. So, and then the same thing, if we have this log to the base b of y equals x, we start with our base to switch to an exponential. We go over to the other side, that's the power, equals, and then we come back across the equal sign and grab the y. So I just think it's kind of an easier way to remember it, as you're kind of going in a circle instead of trying to memorize a formula. All right, so let's use what we just did to solve this. So they want us to rewrite 6 to the -1 equals 1/6 as a logarithmic equation. So we're going to use the 6 here as our base. So that's log to the base 6. Then I go to the other side and I grab the 1/6. So log to the base 6 of 1/6 equals, and then I come back over and get the power -1. So log to the base 6 of 1/6 equals -1. And then when I want to rewrite the log to the base 4 of 64 equals 3, I'm going to again start with my base, which is 4, go over to the other side to the third power equals, and then come back around 64. 4 to the third equals 64. And by the way, guys, we can think in terms of exponents. So we know this means 4 times 4 times 4 equals 64, but our brains do not do logs. So if you're trying to evaluate this by hand and you don't have a calculator, you'll always want to convert it from a log back to an exponent so that you can solve it.